Okay, so now we're on to question 2, paper 2, June 2016. So complete the bubbles in figure 1 by inserting the SI unit which matches each of the physical quantities. So the SI unit for force is Newton, and the SI unit for linear momentum is kg meters per second. It says state Newton's third law of motion. If object, so this is a question where you need to know it or not. A exerts a force on object B, then object B will exert an equal but opposite force on object A. And the next question in question 2 says, a Caribbean airline on its way from the Piarco International Airport to the Grantley Adams International Airport flies horizontally in mid-flight. With the aid of a diagram and using Newton's third law of motion, explain how this happens. So they said, with the aid of a diagram, so I'm going to draw a plane. Okay, that's my plane. And then there are 4 forces acting on the plane to keep it going. You have gravity acting on the plane. You have the upthrust force. Then you have wind resistance, which we can call drag or friction. And then you have the thrust to go forward. All these forces must be acting together in order for the plane to keep moving. If the forces are equal, then the plane wouldn't be moving. Okay, and that's pretty much what you have to write for the next section. So, all right, the plane is able to remain in the air because of 2 pairs of forces. The forces in each set oppose one another according to Newton's third law of motion. However, one force in the pair must be greater to keep the plane moving. The plane is able to stay in the air once its upthrust force is greater than gravity, than the pull of gravity. While a plane is able to move forward once its thrust is greater than the drag on the plane, which is mainly due to wind resistance. So, a plane is able to remain in the air because of two pairs of forces. The forces in each set oppose one another according to Newton's third law of motion. However, one force in the pair must be greater to keep the plane moving. The plane is able to stay in the air once its upthrust force is greater than the pull of gravity, while a plane is able to move forward once its thrust is greater than the drag on the plane, which is mainly due to wind resistance. And that's the answer for question number 2. Question number 2B2. Okay, and now it says define the term linear momentum. So linear momentum is a product of a body's mass and its velocity. So momentum, mass times velocity. So here we go. An 8 kilogram ball traveling to the east at 10 meters per second collides with a 2 kilogram ball traveling to the west with a velocity of 5 meters per second. After the collision, they move together. Determine the final collision or the final velocity of the balls. Assume that there are no resistive forces. So usually I would tell my students to draw it out, and the coordinates on the map that we have are north, west, east, and down the south. Anything going north will be positive. Well, any velocity in the northern direction will be considered positive. Anything going in the eastern direction would be positive. Anything going in the western direction will be termed negative. Anything going in the southern direction will be termed negative. So this is all based on the velocities. So here we have an 8 kilogram ball moving east. So its velocity will be positive. So this is the 8 kg ball. Let me draw it better. So we have an 8 kg ball, and it's moving in the eastern direction as the question says. It says moving east, so we have a velocity of 10 meters per second. And then it's going to collide with a 2 kilogram ball that's moving west with a velocity of 5 meters per second. So it will be negative. Then when they meet, they collide, and and we want to find out the final velocity. So how we find it? So now we have the picture, we have the before and we have the after. So we know that m1 v1 plus m2 v2 is equal to total mass, because they're stuck together. So in this case, we have the total mass Vf. We list it. I'm going to take this as my mass 1 and this as my mass 2. So they must both correspond to each other. So here we have mass 1, so this will be velocity 1. Mass 2, this will be velocity 2. So our mass 1 is equal to 8 kilograms. So velocity 1 will be equal to 10 meters per second. Okay? And then our mass 2 is equal to 2 kilograms. And our velocity 2 will be equal to -5 meters per second. And therefore our Vf will be equal to x. So we could find it out now. We know we could transpose. So Vf will be equal to m1 v1 plus m2 v2 over m1 plus m2. And we just fill in the stuff. So 8 kg times 10 plus 2 kg times -5 meters per second divided by 8 kilograms plus 2 kilograms. And then our Vf will be equal to 80 kilograms meters 80 kilogram meters per second minus 10 kilogram meters per second all over 10 kilograms. So that will give us 70 kilogram meters per second divided by 10 kilograms. Cancel out this, and you're left back with 7 meters per second. I hope that helps. Good luck.